Hi, in this video I'm going to go over a few examples of the applications of vectors. In other words, I'm going to go over some word problems with vectors. So by now we should be pretty familiar with the math skills that we are able to do with vectors, and we're going to see how all these skills can be applied in a real world context. Okay, now go ahead and pause the video. I got this example from the textbook, and please pause the video and see what they are asking you to do. Okay, welcome back. Now I hope you guys read the example. So here they are asking us, so we have two boats, boat A and boat B, right? And boat A has a position vector of R1, right? Boat A has a position vector of R1. And boat B is close to the harbor, and it has a position vector of R2, where the T over here, the T is just time. Okay, same with the position vector of boat A, the T is time. Now for part A, they're asking us how far apart are the two boats at the time the first boat leaves the harbor. Right, so they're asking us when boat A is just about to leave the harbor, how far apart are these two boats. Okay, so part A, we just have to find the distance, right? The distance between the two boats. Distance between the two boats. Okay, now we should be pretty familiar with finding distance between the two boats. In other words, we're sort of finding the distance between 2 points, right? So my boat A has a position vector of T 30, 15. My boat B has a position vector of 50 and 5 plus T 10, 10. Okay, so these are the position vector with respect to time, right? With respect to time. Be careful with that. Okay, so part A, at the time the first boat leaves the harbor, so which means when the first boat is about to leave, which means your time is equal to 0, right? Your time is equal to 0. So my R1 would be 0. Yes, because my T becomes 0. Multiplied by 30. Okay, let me just put this down. Then that my R1 gives me 0. What about my R2? So my R2 is equal to 50 over 5 plus 0 times 10, 10, right? Which means my R2 is 50 and 5. So the position vector of my first boat was at 0, and then my position vector of boat 2 is at 50 and 5. For the boat 1, I'm going to write that in terms of a column vector. So this is going to be 0, 0, which means I am at, boat A is at the harbor. Now, if I don't find the distance between these 2 points, all I have to do is find the distance. So remember, I kept on mentioning the distance between 2 points is very similar to the distance formula, right? In terms of vectors, it's very similar to the distance between 2 points on the xy plane. So what I have here would be 50 minus 0 squared plus 5 minus 0 squared. Okay, and that will give me, this is my distance, right? So my distance between them would be square root of 2525 if you use a calculator, which is approximately 50.2. kilometer, assuming that's the unit. Okay? So that's my part A. Now for part B, how fast is each boat traveling? Right? Now this is a bit tricky. Right? How fast is the boat traveling? So if you think about this, let's look at boat A first. Right? Let's look at boat A. And on the left hand side, I'm gonna have times equal to 0, times equal to 1, times equal to 2, times equal to 3. Just a few points, just to kind of get an idea. So when times equal to 0, my boat A is at 0, 0. When times equal to 1, I'm going to substitute 1 in there, right? I'm going to substitute my 1. Let me change the color in here, right? So when t is equal to 1, my position vector will be 30 and 15. I'm going to zoom in a little bit. When time is equal to 2, I'm going to have 60 and 30. When time is equal to 3, I'm going to have 90 and 45. So on and so forth. Now, how do I find the speed? How do I find how fast is boat A traveling? So you can see that for boat A, for every hour, when I increase the time by 1, which means every hour my position vector goes up by 30, 15, right? So there is a constant rate of change, right? There's a constant rate of change, which tells us how fast is boat A traveling, right? There's a constant rate of change. In other words, that's our velocity, right? That's our velocity. So since my constant rate of change is 30, 15, so for me to find the velocity of boat A will be the magnitude of this 30 constant rate of change, right? That will give me sort of the speed of my boat A. So to find the magnitude of that 30, 15 column position vector, I just have to take square root the sum of their squares, and that gives me approximately 33.5 kilometer per hour. Okay, I hope you guys got that, because we can see that for every time when we increase time by 1 hour, there's a constant increment of this 30, 15, 30, 15, 30, 15, which means that is how fast my boat A is moving, right? Okay, that's for boat A. What about boat B? Let me use a different color. So for boat B, say time is equal to 0, time is equal to 1, time is equal to 2, time is equal to 3, right? So on and so forth. Now, for boat B, when time is equal to 0, it's at 50 and 5. When time is equal to 1, now I'm going to substitute the 1 there, right? I'm going to substitute the y in the t there, and I will have, so this is 50 plus 10, that gives us 60. And 5 plus 10, that's 15. I'm going to zoom in. And then I'm going to plus 10 again, so I will have, when time is equal to 2, I will have 50 plus 20. That's 50 plus 20. Oh, sorry. So which is 70. This is 70. And I'm gonna 5 plus 20, so that's 25. Right? When time equals to 3, time is equal to 3 here, then I'll have 50 plus 30, that's 80. And I will have 5 plus 30, which is 35. Okay. Now, let's see if there's a constant rate of change. There should be, right? There should be. So whenever time goes up by 1, I am adding 10. And then when time goes to 2, I'm adding 10 again, right? And time goes to 3, I'm adding 10 again. So there is this constant rate of change. I'm not sure if you guys see this. This part right there, for my bolt A, is my speed. And this part is my speed for bolt B. Do you see that? Okay? So technically, we don't really have to come up with this table here, right? The table that times equals 0, 1, 2, 3, and over here I have times equals 0, 1, 2, 3, and figure out what are their respective position vectors. I didn't have to do that because from the pattern that we see here, whatever we have at the back, that is that whatever we have at the vector that we're multiplying the time with, that is sort of give us the information on how fast the boats are traveling, right? So now for boat B, I would say the velocity for boat B, actually I should have called that the speed for boat B, will be the magnitude of this 10 vector. Right, so this will be square root of 10 squared plus 10 squared. So that would give us approximately 14.1 kilometer per hour. All right. So when it comes to word problems, it is not as straightforward as the skills that we have learned from the previous sections. Right. When it comes to word problems, it is a little bit more challenging. Okay. Now we've done part A and part B. Now, part C is very interesting. I want you guys to take a look at part C again and think about how you would approach this, okay? I will solve part C in the next video. Bye-bye.